All right, hello everybody and welcome. This is going to be a Google Cloud for Marketers and Overview of Case Studies webinar. To get started, I'll go ahead and introduce myself. My name is Tyler Blatt. I'm an analytics engineer, which specifically specializing in cloud solutions for large organizations, and I tend to focus on serverless solutions. Previously, before I did that, I was focused on global tag management architectures, so tag management architectures for large companies spanning, across the globe. And my background is in MVC application development. I'm going to pass it over to my partner here, Pam, and let her introduce herself.
Hi, everyone. My name is Pam Castro-Cohn. I am a lead on our data science team here at InfoTrust. Also working with some of the largest brands and companies in the world. My background is math and statistics, and so I am interested in the predictive analytics and machine learning side of things, which we'll touch on a tiny bit in today's webinar. And then outside of work, I am an adjunct at the University of Cincinnati, teaching a course on digital analytics.
All right, and now that you know us, I'll introduce you to InfoTrust if you haven't heard about us. We're an independent digital analytics consultancy based in Cincinnati, but we also have offices in Chicago, Barcelona, and Dubai. Our goal or mission statement is to help our clients become data confident. You can see here on the left the ways that we aim to help companies increase their ROI is through data compliance and security, digital architecture and data integration, technical implementation and support, reporting and insights, and digital analytics strategy and data science. And then on the right, you can see, obviously, we're a Google Marketing Platform Suite and certified. So this is basically to highlight what makes us different than other companies that are kind of in the field doing the same thing. We build our own products, so we have a product called Tag Inspector, which is essentially a way to do auditing across your website and all your tagging implementation. So when we see solutions or things that aren't being done in the field, we'll build our own products. We have a lot of experience in this field, 25 plus Fortune 500 companies, clients, 6,000 websites supported each year, so we're all over the place. And then, like I said before, we're all over the place. We have Cincinnati, Chicago, Dubai, and Barcelona offices, which means we have somebody on our team around the clock, basically, able to do support. And if you get support at what would be off hours for your company, it's always somebody that's not farmed out for support, but it's a real InfoTrust employee. And so we've kind of strategically placed ourselves around the globe. TMS agnostic. Like I said before, I was previously in global tag management solutions, so I've personally touched on all TMS platforms that are out there right now. We're trained in experience. We move people from one to the other. We've done a lot of work around that. This one I'd really like to highlight. ROI is our priority. We have no plans to sell you your media, so while we're working around media strategy, our goal is always to make you more money, not to sell you more things. So we're almost like fiduciaries in that area. We purely have your best interest at heart. And we're trusted advisors. 94% of our customer stay with us. We have a great retention rate, and we have a NPS score of 7. And before we jump into it, the last thing I wanted to show you is kind of a concept of how we grade where certain companies are in their scale of kind of digital analytics and where they're headed and how to get there, what the different states mean. So I just want to explain to you, I'll kind of talk about this at some points during the webinar, so I want you to understand the terminology. Crawl would be somebody who's doesn't really have a great concept of where their tagging architecture is yet, so they're just now starting to figure out how their tagging is working. They're understanding their tag management services. They're starting to build a strategy to how they're going to get their data collection working, and they kind of have some basic analysis going on, but they don't really know what they're doing with their data yet. When you're getting to walking, that's when people start to talk about getting the GA360 license, which is going to give them some basically better advantages with integrating their analytics with their marketing suite and higher or lower sampling rates and that kind of thing to make the data a little bit more richer, and it's better for that kind of advanced analysis and tying it in with other platforms. That's where enhanced e-commerce implementation starts to happen. So they're really starting to understand their e-commerce platforms and the data around it. The tag deployment across different areas is now automated, so every pixel isn't a request that takes weeks, but instead we're able to roll out things on a larger scale more quickly. And then there's pretty standard reporting around it. And then run is when we really start to do cool stuff with the data. A lot of what we're going to try to talk about at the end will be closer to the run stage, but you can do the things that we're going to talk about at any stage, given that you have the right data collected to be able to do them. So I don't want to have people not be interested if they're like, well, I think we're in crawl. But a lot of the things that we're going to talk about towards the end as examples of what we can do cool with the Google Cloud Suite, specifically for marketing, is closer to people that are in the run state, and now they have their data set up and they're ready to start doing really cool stuff with it. That's where you start seeing things like a CRM integration, so linking the customer data with the analytics data. The media attribution analysis, you get really advanced analytics using BigQuery. We'll talk a lot about BigQuery today. And then CLV analysis, which is one of our examples we'll talk about later on in the slides. So here's our agenda today. First things first, I want to make sure everybody's caught up on what the keywords are in cloud. I think there's a lot of buzzwords out there today, so I'm going to make sure everybody's speaking the same language first. And then once we're all on the same page, I'm going to pass it over to Pam, and we're going to talk a little bit about BigQuery. And then we'll do an overview of the Google Cloud products. We're not going to do all the products, but a good chunk of them and how they apply to really the marketing suite. And then we'll go through a couple example problems and then solutions, how we use the Google Cloud. And then at the end, we'll do a couple upcoming events for other things at InfoTrust and webinars and such. All right, so let's dive in. So the first keywords that I wanted to get nailed down for everybody is explaining structured versus unstructured data. And what does that mean? So essentially what structured data means is just that it has to have a structure. It needs to be formed in a certain way. So the example that I have here is an email and phone number. So if you see the first two with first names, I could pretty much, for first name and last name, put anything in those fields. I actually used the form field for this exact webinar as the example here. And I could put anything I wanted in for first name or last name. But email has to have a certain structure where I get those, please fill out your email, please fill out your phone. I was getting those errors back because it didn't follow a structure. So sometimes when we collect data and we're going to use that data, it has to have a certain structure. In this case, the phone and email didn't follow that structure. So this is an example of data that has to have a specific structure to serve a specific purpose. So what would an example of unstructured data be? How can we help you? Never have you put things into a contact us, how can you help us field, and they've said, no, it needs to be in this form. Nobody corrects grammar or anything. It's completely unstructured. You have the freedom to put whatever you want in here, but that makes analyzing that data kind of harder because it's in that unstructured format. You don't know exactly what's going to happen. So when we talk about structured and unstructured data, it's just that difference. So the next key differences that we're going to cover is raw versus processed. So when you talk about raw data, it's in the exact form that we collected it. So I gave the example of this contact us form. And if we were to collect this data and store it somewhere in this exact format, it would be considered raw. However, I went too far. If I wanted to learn some things about this, let's say I wanted to talk to my acquisitions team and they wanted to find people that have filled this out and go find people that were interested in the word analytics. So if I were to search all of the contact us forms and look for, if we use this specific one example, did it contain analytics? I might have a table of all the customers that had a comment that contained analytics. And then we could also use tag management. So now we were able to process these raw tables into processed tables that hold values. Now, the reason that you want to store raw data, because some of you might be thinking, like, if your goal was to find out if it contains certain words, why would you ever store the raw data? Why wouldn't you just process it and store that? Is we might, right now, the only thing we're looking for is analytics, tag management, and governance, and whether it was included. But later, we might want to know, Did they put the word InfoTrust in there? And if we process it now and only store the process results, we can never find other insights from it later. So the reason that raw is an advantage is because it allows for finding other insights down the road that we didn't know we were looking for, but we collected the raw data, so now we can look at it. It makes our data sets a little bit richer, which is going to be applied to our next concept that we're going to talk about, which is data lakes versus data warehouses. So both of these words are everywhere, and I'm seeing them being interchanged a lot. They have some subtle differences, though. What a data lake is meant to be is, here are the words we've been talking about, raw structured and unstructured. So it can be structured or unstructured, but it should be raw data. That it's this next point that is the reason that it should be raw. It's good for exploratory analysis. So if I actually jump back, and I brought up the InfoTrust, please help, and we want to know if InfoTrust was in there. If you wanted to explore that data, but we didn't store the raw, you could never find that information. So obviously this is sort of a silly example, but when you think of this to your company, you might have certain data points that you're collecting and then processing and not storing the full thing. So if you want to build a data lake, the reason people say this for like data science and other things is you need a lot of information to be able to perform these types of activities against your data. So if you want to do this analysis, data lakes are specifically raw, and that's why they're good for exploratory analysis. And again, that's why they hold limitless potential for insights, because you continue to look at the data differently over time as you think of new ways to interact with those data points. And like I've said, it's a prerequisite for data science. Data warehouses, on the other hand, are processed and structured. So it's data that's been, if it didn't need to be processed, such as like names don't need to be processed, but they're still sort of structured. Basically, a data warehouse is for a specific use. If you think of just these words in general, if you think of a lake kind of, it doesn't have lines drawn in a perfect circle. It kind of, the beach around the lake might be a little murkier and not definitive. But a warehouse, you see lots of different siloed things for a specific purpose. They move things around in a specific order, and that's exactly what a data warehouse is supposed to represent. So that in that purpose, it's specifically good for dashboarding and presenting things because we've taken that raw, unstructured data and then processed it into a very structured, presentable way so that it's there for reporting on and doing other types of things around that. So the tables are always designed for solving a specific problem. And a good company should have both of these side by side. You should have a great data lake, and then from that data lake, you should be processing it into good, reusable things in the data warehouse. The last keyword we're going to talk about is serverless. It's all over the place these days. It's known as like one of the better ways to save money in the cloud, but a lot of people don't know what it means. So I'm going to try to do a little bit quicker explanation of just what serverless means and why it is something that's getting so popular. Basically, if you hear dedicated server or you hear like web hosting and those types of words that you heard in the past, what a server basically means is a computer. It's a computer somewhere out on the web that is not a computer that's in your office. And what we've had to do in the past is take that physical machine or that cluster of physical computers, physical machines, and set them up and maintain them and make sure that they're still running well. So you can think of it sort of like a rental home. We're renting it, but we also have to maintain it and keep it clean and keep everything good. And then it takes time if you need to scale that. So let's say we needed 3 computers processing, but now we need 4 computers processing. You have to manually go out and rent that 4th computer and set it up to be able to be a part of your cluster of other computers processing together. And the other part that is kind of a negative to dedicated servers is they can be expensive and often aren't fully utilized. Once we needed that 4th computer, we're probably only using 10% of it for a while until that gets the max, then we're only using 10% of the 5th. So what does serverless mean? Well, essentially these large companies have kind of realized we have a whole lot of machines out there and people aren't renting all of them. So what we can do is, if we're going to use the house example again, kind of do timeshare on those. So basically what you're doing with serverless platforms is you're setting your code up to be able to be ran on any machine. And then what ends up happening is they're able to scale that as fast as they want because there's a whole sea of machines out there ready to run your code. So you don't have to maintain the servers because these companies are taking care of the servers. They'll automatically scale for you because they're already set up to run on as many machines as they want. So as they get requests, they can just find a machine and go run the code. They're way cheaper because you're not paying for that overhead of holding the machine. You only use it when you need it. And because it's kind of built in a modular style way, it actually helps support better development practices. So you can build things kind of a little bit more modularly and don't have to build in large scale applications for a lot of these smaller problems. All right, I'm going to send out a poll real quick just to find out if you guys thought that that section was helpful. We'll wait probably 20 or 30 seconds and then we'll jump out. Okay, it looks like we got most of the votes in.
Cool. So one thing I want to say before we dive into the next section is if you have any questions about anything as we're going through, feel free to post your questions into GoToWebinar. We're going to proceed through our content and then we'll review the questions at the end. So just sit tight and we'll get to them. But certainly if you have any questions, especially over the background slides that Tyler just went over, feel free and we'll circle back around to them toward the end of the hour. Okay, so let's talk about BigQuery. And before we do that, I'm going to provide a little bit of context. So as we mentioned at the beginning, I'm on our data science team, Tyler's on our engineering team. And so the reason we decided to pair up for this webinar is because we often work together. So the data science team will get different predictive modeling projects. And so my team uses BigQuery a lot so that we can create the data sets that we need to build our models from. But then once it becomes time to move those models into production, we work really closely with Tyler and his team and utilizing Google Cloud to move those models from just being run one time to being run in production on an ongoing basis. So that being said, let me talk a little bit about BigQuery. So BigQuery is Google Cloud Platform's enterprise data warehouse. And so to circle back on a slide just a moment ago, you can use it as both a data lake or as a data warehouse. It actually is considered a hybrid database. So it has features of both a relational database as well as a NoSQL database. There are a number of reasons why we like it. First of all, it's fully managed, so it's really easy for us to get up and running with it. It's also really easy to use. I typically run my queries in the browser, but you can also run them in the command line. You can use the BigQuery API. So people with different skill sets can use it in different ways. So another reason that we use it a lot is because as part of Google Cloud, it's also integrated with Google Analytics 360. So why that's important. So when you have Google Analytics, you can obviously use the web interface to view the different reports and see what your users are doing on your website. There are a lot of reports in the UI, but as companies are becoming more mature in their analytics journey, they often have more and more questions that can't be answered through those pre-built reports in the Google Analytics interface. So when companies upgrade from the free version of Google Analytics to Google Analytics 360, one of the benefits is that you can link BigQuery with Google Analytics, and you can use BigQuery to store the full unsampled hit-level data that's being collected from your property. So that is a huge benefit for those companies, like I said, that have questions they can't answer in the UI, or for integrating other data sources and then wanting to involve an advanced analytics or data science team to build models around or models using that data. Some other benefits. BigQuery is really fast. You can use it to process enormous amounts of data, and it will return it within seconds. And it's easy to use. It uses its own SQL type dialect, so that's generally really familiar to either data science or BI teams. A couple other benefits: it's reliable, it's scalable, and then just in terms of cost compared to other products out there, it's pretty darn affordable. So that being said, I'm going to pass it back to Tyler, and he's going to take us through a number of the other products and services within Google Cloud.
Before we do that, we got a question from Tony asking, is it possible to utilize the GA to BigQuery connection even without a 360 account? The answer is no, yes. So just out of the box, so one of the beautiful things about with 360 is it's just a checkbox. You just go into the analytics dashboard, and it's just a checkbox that you can pull on. But to highlight some of the custom and creative things that we do at engineering here, something that you could potentially do if you're wanting to send some of your data or figure out a solution around that is you could set up. I'll give a better example of this sort of towards the end, but you actually use the Google Cloud to also solve that problem of not having 360 yet, but wanting to get that portion where you would set up essentially an HTTP port or a web port, a place that you could send a hit, much like your tags already work, that takes that hit in and just sends it straight to BigQuery. So that's a way to do it, but it's going to be a lot of networking and a lot of cost, which is why you find out why the 360 license costs what it does. So yeah, it wouldn't be free, but it's definitely possible, and you would pay some amount for that cloud function and the storage in BigQuery, but you could get that done. If you have more specifics about that question, feel free to reach out to us. All right, moving along. So that was BigQuery. We're going to jump into an overview of kind of like all of the Google Cloud products and the different like world that they cover. So the first thing that we'll look at is big data and what the different products that they offer for dealing with your big data sets. So I'll skip right over BigQuery because we just talked about it, and I'm probably not going to go as deep as Pam went into BigQuery with the rest of these. And I'll touch on PubSub real quick. So what PubSub is short for is publisher/subscriber. And what that means is when something happens in the cloud and you want to let everyone know, you would be a publisher sending out a message to everyone. And if you wanted to listen for certain messages to be sent and then do something else, you would be a subscriber. To give you an example, maybe you can't get your marketing data from an API. Maybe it's just a file upload. So you tell them upload to this bucket every day and just drop this file. Well, what you would want is that bucket to be a publisher and say, hey, everybody got the file, and then all the subscribers to that message would come, consume the file, and do whatever they have to do. So what it is it's the ability to kind of listen and wait for things and then take actions after that within the cloud, and that's that service. Which pairs nicely with Dataflow. What Dataflow is Google's premier ETL solution. If you don't know what ETL stands for, it's extract, transform, load, which means extract, get data from somewhere. So it might be a file store or an API. It could be streaming data from a database. Anywhere it'll extract. It's pretty agnostic of where it can extract for. Transform is go back to raw versus processed. If we didn't need to transform, we'd just be storing raw data. But if we need to process the data before we're ultimately storing it somewhere else, we need to transform it. So what do we have to do? And that's the transform layer of that. And then load would be L, store it somewhere. So do we want to store this data in BigQuery or another one of the database solutions, which I'll talk about in a few slides. But yeah, Dataflow is basically a nice wrapper for being able to do that in a serverless way. It's also serverless Dataflow is, so you don't have to manage any servers, and it's auto-scaling. So if you get more data coming in, it'll automatically handle the large data sets, and it'll go ahead and process your data daily. So it's a nice little architecture to wrap all that. Data proc is just a nice way of managing your Hadoop and Spark clusters in the cloud. I imagine that probably sounds like a foreign language to some of you. Spark and Hadoop, what they are is I talked earlier about needing 4 or 5 machines out in the cloud. So if you had a service where you needed to send some information off to get processed, and you were using maybe 4 machines or 5 machines, you have to program those machines to know how to work within a network of each other. So if I want to split out, 4 or 5 split a request into 5 pieces and have it just handled for me. That's what Spark and Hadoop are great at doing, is managing these different machines that you're using for processing. And Dataproc is Google's solution to managing that. So if you have a team that uses Spark and Hadoop, you'd love to look into Dataproc. However, if you're not currently using those, not as important. The last one that we'll touch on here is Data Lab. And it's essentially a playground for playing with your BigQuery tables. So it allows you to do some visualizations and some analysis and even some data science on top of your data. And it's exactly that. It's a laboratory. You're in there doing science with your data. So it's just a fun way to look at all that. Quickly, I wanted to go over kind of a visual of what data flow looks like. We have a lot of technologies to go over, so I won't spend too much time. But you see here, there's kind of an ingest part where you have cloud data store, which is where that it might be a database that's streaming data in, so it's its ability to stream, and then there might be processing data in batches, which is where you see the pub sub. And then once that data is processed, we need to store it somewhere. So Dataflow will do the processing, and it kind of also sparks the extraction as well, and then it sends off to load that data somewhere. So it might load it into the cloud machine learning, or it might load it into Bigtable for showing that data somewhere, or it might load it into BigQuery where you can store it in a data warehouse, and then if it was in the data warehouse, you could also use Data Studio to display it, so that it's now that's one of the big things of BigQuery that we didn't necessarily touch on yet, but we'll touch on more when we do the examples later. But basically with BigQuery, whenever you have a finished table, you can click just to explore it in Data Studio. It's one button click away, and you already have visualizations on top of that table, and you can start customizing and making the dashboard look really nice. So that's just kind of like a visual example of how you might be working with your big data with these data sets. So storage, and you might be saying storage, you just showed me BigQuery, why do I need to store with anything else? So there's a couple of different types of storage you might need and a couple of different purposes you might want to use them. BigQuery in itself is not really designed to be used as like a production database. It's meant for almost what it's named, to write big queries. It's to store big data and do big sums and big aggregates, and because it's serverless and scalable, it is able to take a lot of machines and go against your one database really quickly and get big results, but you're limited to updates and deletes a day. It's meant for big data collection and big data warehouses and data lakes, not for production databases. So that's more what this storage part of Google Cloud is working for you. So if you end up having tables that you want to have a quick response time, that's what Bigtable is designed for. And I think Google uses that internally for Gmail and their search engine. And that's when you think of Gmail or the search engine, I'm getting quick results back. It's not a ton of results, it's just very quickly they're returning the information. Cloud storage, on the other hand, is file storage for Google Cloud. So that's if you needed to drop a CSV and have it be processed, or you needed something to happen there, that's what cloud storage is going to do for you. It's buckets for you to be able to store things. We'll talk about it a little bit more later, but in one of the solutions we're going to talk about, we needed to store models for data science, and that's where the models get stored. It's a place for us to hold things. Cloud SQL is if you're developing an application and you just need I forgot the name of it, but basically a SQL database to work with your application. And then Cloud Data Store is the NoSQL equivalent to that. So it's the NoSQL database for you to just spin up and be scalable. Okay, so compute is their answer to machines, there being the Google Cloud Platform's answer to machines. App Engine is going to be, I talked earlier about dedicated servers. So I'm going to go in reverse here because I think it'll make it a little bit easier. Compute Engine is just a dedicated server. You're just renting a machine on the cloud and you maintain it and you go in and you operate on it, and they have a couple nice to haves with it, but that is just, I have a computer that I'm renting in the cloud and I can just remote into, and it's like I'm on my own computer. And then you have Container Engine, which if you guys have heard of like Docker or Kubernetes, which if you haven't, what those platforms are is basically a set of instructions for mirroring an environment, so that if someone were to steal your computer, you could run these container settings and it would be like your code's running in that exact same environment. So no matter what the computer is, it's a set of instructions to making sure the code's always running in the same environment. And Container Engine is a way of managing those services. And then finally, App Engine is stripped down to only select certain frameworks and instructional sets, and it's meant for writing smaller scale apps that you can spin up really quickly, and you don't have to manage the server or do any that kind of stuff. You simply just deploy the code and the set of instructions, and it'll run for you. So that's a bit more of a lightweight, get things serving very, very quickly. And these are for any kind of solutions you want to put out there to manage an application that's being interfaced with. There's one thing on compute that I'm going to talk about later that isn't actually on this slide, but there's also cloud functions, which is basically just running a piece of code anywhere, anytime. So cloud functions is completely serverless, and let's say you had something like, I want to extract all of my Google Analytics data for this day, every day, and then do this thing to it and then load it into BigQuery. You could do that in just a cloud function. It's basically just a piece of code that is compiled to be run serverless in the Google Cloud. And then the last thing that we'll touch on before we jump into the examples, I know this might be a lot to take in, is the machine learning section, which we'll just kind of touch on the capabilities of these. I think it might be a little bit much to get in too far into how they work, but which is what can they do for you guys as marketers. The Vision API essentially will take a set of images and add tags to it, so it'll classify them for you. And what you can do with that is take those classifications and do kind of some analytics or analysis on top of it. You could use some data science to find out of all of my marketing creatives, if I took the tags, what are the tags on my highest performing marketing creatives, and what are the tags on my lowest performing, and what could I potentially do to alter these images to get better tags, and then I could kind of throw them back into that Vision API and say, okay, now I'm getting the right tags, these should perform better. So essentially you can use those tags to use some analysis to find out why certain creatives are doing better and what kind of tags get associated with them. The machine learning is essentially a platform for discovering, it's a platform for machine learning, but if you're not aware of what that kind of looks like under the hood, it's basically, I have this data set and I have these assumptions against this data set, so I'm going to have you try this, and this until I can find out what's giving me the best results with that. So being able to process through that data on multiple machines and try different assumptions or questions against those, it'll handle all of that for you. So you're able to just load the data set in, essentially load the questions and what would be the best result, and then it'll tell you using this is what your best result should be, basically. The speech API is, it will take either text to speech, which is cool, or you can also do with speech to text, but then also you have the ability to judge sentiment with people's responses. So if you have like a reviews section on your website and you want to know how many of my reviews were positive, it'll help you take what those reviews were and give you a grade on this person was really happy or this person was really sad. So they have kind of things like that for dealing with speech. And then I bet you can guess what Translate API does, but it translates the words into other languages. So those are some of the cool features that you can get with machine learning section. Okay, so that is the end of our overview, and now we're going to step into a couple examples and problems. But first, before we do that, I was going to make a flow like this for some of these example problems, just as the solutions, but I realized in essence they're all pretty much the same. So this is just an example of getting some of your data into BigQuery a couple of different ways. So you might have a file that gets dropped into cloud storage, so then you have PubSub drop the file and then push it into Dataflow, and it gets processed and goes into BigQuery. You might just have data flow connecting to some streaming data service or some other API, and it goes right into BigQuery. Or maybe your team doesn't work with data flow yet, and they already have the API connection written up, and they know how to move the data. They just need it to be ran in the cloud. You could just use cloud functions. You already have the piece of code written, so you can just have a cloud function connect to BigQuery, which is easy because it's easy to connect to BigQuery when it's running in the same cloud instances. So the integration is very simple. So maybe they just want to use cloud functions. These are a couple different ways that you could work to getting your data all in one place so you could be ready to run these things that we're about to look at. And I'm going to pass over to Pam, and the way that we're going to do this section is she's kind of going to explain to you what the problem is and kind of the way to get to it, and I'm going to explain some of the cloud things that help get this done.
Right. So the first example we want to touch on today is around customer lifetime value. CLV is a really hot topic right now, and the reason for that is because we're seeing so many of the organizations that we work with pivoting their marketing strategy. They're moving from a kind of narrow focus on, maybe the first interaction with the customer or just getting them back to the site again. And instead, they're switching to more of a user-level, customer-centric type strategy that's more long-term focused instead of just driving the next conversion. And so what CLV modeling does for you is that it utilizes different predictive models, and it actually predicts how many future orders each customer in your customer base will make. And then it also can predict how much they will spend on those orders. So you have this, projected cash flow going into the future, and then actually gets discounted back to present value. But ultimately, it's able to put a dollar amount on the future value of that particular customer, and how valuable they are to your company or brand. And so the reason this is important is because, as I think most marketers acknowledge nowadays, is that not all customers are created equal. They are not all equally valuable to the brand. We sometimes hear people talk about the Pareto principle or 80-20, in that there's a small core of that customer base that's driving a disproportionate amount of the value. So maybe it is, your best 20% of customers are actually driving 80% of your business. So CLV gives us a way to identify those customers and rank them so that you can tell, who are the most valuable, separate them out, and then, ultimately, you can better serve them. You can tailor your experiences for them, nurture your relationship so that they can continue to provide value to your brand for many years into the future. So that being said, we use different types of predictive models to predict out each customer's customer lifetime value. And then what we do with that is that we basically push it into another platform so that it's actionable for marketing. So that might be back into Google Analytics so that you can leverage the integration between GA and AdWords or the other marketing platforms. Or we've also in the past have pushed it into like a CRM or a CDP, a customer data platform. So that being said, Tyler, how does cloud play into solving this type of problem?
So the number one thing that I would say when working with CLV is we need a lot of data. And we need a lot of data about the customers, at least historically. So going back, so we need to be able to see the patterns of what they're doing and what makes a customer more valuable. And then quantitative fields about like why they're more valuable. I'll go back. I said this would be a little bit repetitive across some of the slides. We need to get the information into BigQuery. So for the ability to be able to do that data science in it, we have to collect all the information that you may have some web information versus offline information, or you have all of your information offline and stored over here. So we need to make sure that we have it all in the place that we're going to be doing the work. So the first step is get the information into BigQuery. And then from there, because I'm working with Pam, who's a data scientist, she needs to work on connecting to BigQuery and doing her model. But we need the ability to do that offline in the future. So maybe we want to, with CLV, sometimes it's a one pass analysis. We basically create that. But if we want to be able to repeat that in the future, we would want to be able to offload that to a computer. Or another problem, and anyone that's done data science would know this, is it's sort of machine intensive. So if she needs to do a couple passes on this data and she wants to try a couple different things out, but she doesn't want to have to wait a day of processing on her computer and then another day and another day. What you could do is, I'll go back to Compute Engine, which I told you is basically renting a machine in the cloud. So if she wanted to set this up to where she needed to run 5 tests and each of them took a day, she could spin up 5 compute engines today, run the test on all 5, and at the end of the day, she has her results and she didn't have to wait a week. So that's a way that Google Cloud takes your problems and makes them a little bit easier. This is also a good example for Google's machine learning API, but it's a little bit more complicated to work with and it's still in beta. So it's something that maybe isn't the first step that you wanted to take if you were at the crawling or walking stages, but if you were running, that might be something that you want to tackle that could help solve the problem. And it does that machine striping and testing different things that I said Pam would be doing for input for you. So that's a strength. Real quick, before we go on to the next example, I wanted to address a question that came in. Is there an advantage to using cloud functions versus Google Apps Scripts? So when I think of cost, obviously Google Apps Scripts, because they cost nothing. You're basically just running something in the background, but it's only JavaScript, and it's not great at dealing with like large data sets or fast processing, and it's not as easily integrated with the cloud. So if you have something working in app scripts, I wouldn't say move it to cloud function now. Like if it's already working, it's great, but it's not really a finished solution. I wouldn't call app scripts isn't like something that I'd like a really important production thing to be running in, because it's a little bit harder to get set up the quality as far as testing and having like, you can get email alerts set up with app script, but it's a little bit harder to get that set up for like production quality code, where when I think of cloud functions, it's a lot more efficient. It can handle a lot more data. It's a lot faster, and there's a lot of things that tell you if it went wrong, what didn't happen at what time, that kind of information. But if you have something that's already solid and working in AppScript, I think it's fine to leave it that way. Okay, moving on.
Okay, so this next use case is around what we refer to as customer journey mapping. So our team's actually been getting quite a few questions lately from our clients around how do they understand how their users are moving through either their website or their app. So getting an understanding of those sequences of events that maybe lead to conversion or maybe don't. And so if you're familiar with Google Analytics reporting, GA has some reports that are built to try to help with this, but in my opinion, they're really difficult to use because they're trying to show you everything at once, and it's really hard to glean any insights from them. So for that reason, we've had much more success in doing this type of analysis in BigQuery. So this would be a case where you can't really get your answer from the UI, and so being able to leverage that integration helps us to answer the question that's coming from our internal teams. So what we've done here is basically we were doing a lot of querying of the Google Analytics data in BigQuery, creating these paths, aggregating, doing analysis on them. Tyler will talk in a moment about kind of how we have this running in production so that the report refreshes on a daily basis. And then what you're seeing in the screenshot is the dashboard that we built in Google Data Studio to visualize this data and make it easily accessible to the internal teams that need it. So that being said, Tyler, you want to talk about how all this came together?
Yeah. So once again, like I said in the first slide of this section of the presentation, you got to get the data all in one place. In this case, we're talking about BigQuery data linked to Google Analytics data, so it's a click of a button. So that's just something where Google Cloud is working for you and it's going to get you there. Then obviously, if you think of all of these problems as I talk through them, it's kind of going to be like, how did we get the data there? What kind of analysis did we do on it? And then like, what action did we take with that analysis? It's kind of like the three chunks. So if I cut up into that, getting the data there in this case is actually pretty easy, just because Google likes to help sometimes. So if we move on to the analysis part, there's some code or some analysis that needs to be run to identify this kind of a pathing analysis and find out what's best. So that needs to be ran and served somewhere. So if you look at this, this is a good example of, I talked about with compute, maybe you want to rent a computer. Container engine is probably confusing for some of you because you don't think of coding environments. But then I said app engine is when you want to process something and serve up some results. So this is a great example for that. We now have the data's already in BigQuery. If we make an app engine instance, it can already see that BigQuery data, and it essentially runs the analysis that Pam's talking about and returns the results. So you can think of it as like a mini web app. With app application. It's not like a full scale, like you wouldn't want to build your whole website in this, but if you're doing a mini solution like this where it's doing some processing and showing results, a perfect example for App Engine. So it'll run the analysis and then it'll just return those results with this page. And so, cool.
All right, the next one is also an analysis that we displayed using Data Studio. Many of our clients are the large multi-brand organizations, and so they often structure their Google Analytics so that they have different properties for their different brands, and they often have different properties for their different markets. So whether that, US versus Canada versus the different countries that they serve globally. And so it can be challenging to get a global aggregate view across whether it's all those different markets or all of those different brands. So this is another case similar to the last example where we leveraged App Engine and BigQuery to do that processing, aggregate the data, and then utilized Data Studio to visualize the results of that aggregated data and then obviously make that easy to distribute within the organization.
Cool.
Anything you want to add?
No, I think it's pretty similar to the last, pretty straightforward, I think.
Cool.
Gone.
Okay, so the next example is around remarketing lists. So a remarketing list, just make sure we're all on the same page, is a collection of typically cookies that where we want to target with a specific marketing message. So there are numerous different ways that you can create marketing lists, but one of the coolest examples that I can share with you is basically where we, or basically where you have a predictive model that is at the customer level, and it predicts the probability that each of those customers will convert. And then based on those customers that are most likely, you can create a remarketing list just for them so that they can be targeted with custom messaging. So maybe you want a more aggressive or messaging for them because you know that they really looked like a customer that would convert. So this was really cool. I actually came across an article from Google and their code repo that they shared, walking through a way that you can do this yourself. So not only can you identify those customers that are likely to convert, what we also advise our clients to do is utilize the lookalike audience feature within AdWords. And what that does is basically you give it your known list of users, so the ones that you would have identified from your model, and then you say to Google, go out and find other people who don't know my brand, but who look just like that group, that I identified. So that can be a really effective way to get your messaging in front of more people who are really promising prospects.
Cool. I'm not going to go too far into technical on this one because it's pretty similar to the way I broke things down, and we're getting lower on time. But essentially, the big one, like I've said on all of these, is collecting the data up front and getting it into one place so we can do this analysis. And similar to the other ways that I've talked about, we can do the analysis through compute engine, app engine, cloud functions. That analysis can be performed or locally if you just want to do it on your own computer against BigQuery. It depends on if it needs a run again in the future. But once that's done, it's a similar process to the other problems.
All right, and then our last one today, we're going to talk about our revenue forecasting tool. I actually did a webinar last month that was solely focused on this. So we're just going to do the quick, 30-second overview here. But basically, our client came to us asking for intraday revenue forecasts, which I know to a lot of people sounds like a really high level of precision and very granular. But their use case was they are a luxury makeup and skincare company, and Black Friday, Cyber Monday, those big promotional days are extremely important for their business. So they wanted visibility earlier in to like a Black Friday of whether or not they're on track to meet their sales targets, because they have marketing contingency plans if things are not on track. So being able to come in Black Friday morning, see from our forecasts whether or not they're on track or not, can help them pivot their strategy and maybe recover if for some reason they're not on the right track to meet those targets. So we built out this tool. We have dashboarding around it in both Google Sheets and Data Studio, so that those brands can use it, and it updates about every 15 minutes.
Cool. So I will talk about a little bit, and this is actually, if you're still hanging around, Tony, you'll find this interesting because we've done some of this with AppScript, so I'll get to that point. The way that we set this up is essentially first we had to create an integration with BigQuery that would have all of the information available for that model early on. And what we found was Google has, if you're not aware with the Google 360 BigQuery integration, there are two options that you can choose. One is every 8 hours, send a chunk of the last 8 hours, and then at the end of that, you'll have that cuts up into 24-hour days, and they'll fragment the daily table and cache that table. Or you can do intraday streaming, which is another way that BigQuery gets information. But what we found was the frequency and the speed of what we were hitting, we weren't necessarily always able to get all of the information from BigQuery intraday streaming. So we actually had to develop a system with intraday streaming and hitting the Google API, the Google Analytics API, to consume that data. And with those two complementing each other, we found that we were able to get 100% accuracy of pulling in that transactional data quickly. And so once we had built the right data set, I worked with Pam and team to get the models set up, and we actually used Google Cloud storage to store cached versions of the models so that we were able to save processing time. For those of you that don't know technically exactly what that means, basically it was so the program doesn't have to run every time. We already ran half the program because the model's unchanging, so it's already in a run state, and we simply give it numbers and it outputs. It doesn't have to rebuild itself every time. So that's another Google Cloud part that helped. And then we used App Engine to help kind of run all of this. So it runs every so often. We would hit the App Engine instance, and it would go to BigQuery, go to Google Analytics, get all the information, pass it to the model, go to cloud storage, and get that model loaded, and then get the output and write it to a BigQuery table. And that's basically that life cycle of that part of it. But to talk about the AppScripts part just a little bit and how that fit in, we had a need. We would like to use Data Studio for this dashboarding that you're seeing on the right side, but just because it's a little bit nicer looking of a dashboard. But we had the need of being able to refresh it, and Data Studio doesn't have the ability to refresh like every minute right now. And since they're wanting to see that production, go ahead, man.
Sorry not to interrupt. We have a workaround for that, though. There's a Google Chrome extension that will auto refresh it, so we do have it in Data Studio.
So at the time, this is why we used Google Scripts, or Google Sheets with AppScript. And so what we did was with AppScript, we hit this this Sheets page and then uploaded in these visuals and got the numbers from BigQuery. So we just did AppScript to BigQuery to be able to get these and display these and update them. And we actually wrote email alerts within our sheets so that we'd be able to know if the service was down. Obviously, if it means a lot to them on Black Friday, they want to know right when it goes down, and we have to fix it very quickly. So that we wrote, like I said before, there's ways to get kind of good production practice into AppScript, and we've done our best. But I think Cloud Functions, I'll know when things failed a lot sooner from Cloud Functions than with AppScript. So that's kind of a good example of how I tried to answer your question there. Okay, and that's through our last example of problems and solutions. So real quickly, I'm going to give you guys a taste of what's upcoming at InfoTrust. So spring of Google Analytics, spring is almost up, but we have plenty of webinars still coming your way. We had the Google Analytics Roadshow just went on. A taste of the upcoming webinars. We have Winning with Media and Analytics in the CPG Space. That's going to be hosted by Chris. He's the man. Head of CPG and multi-brand vertical at InfoTrust. Super awesome. You're also going to have Brad, who's our VP of Partnerships. That would be a great one to join. Those guys are awesome. And then we also have the value of integrating your analytics platform with your CRM. We talked about that as one of the ways to get from walk, crawl, run at the very beginning. This is super valuable. It's a way to make your data a lot more actionable. I believe this will be led by Amin, but we're not sure yet. And you can join us on August 1st for that one. So with that, that brings us to the end. I'm going to launch out a poll question for you guys, and if you have any other questions, feel free to reach out. All right, I don't have any questions coming in, guys, and it looks like it's 2 o'clock at the end of the hour, so I'm going to go ahead and shut it down. Thanks for joining, everybody, and everybody have a nice day.
Thank you.